So could you see my slides now, please?
Yes, we can see your screen. You can start.
So is it on the full screen?
Sorry?
It's full screen.
Okay, thank you.
Go ahead.
Yes, okay.
So hi everyone, my name is Shokat, lecturer at the University of Mosul College of Engineering, Computer Department. My research area has been in the field of dependable embedded cyber-physical systems and fault tolerance techniques. Today, I am here to present to you a paper entitled Realization of a 16-bit MIPS RISC pipeline processor. Field programmable gates array FPGAs are specific family of integrated circuits that are used for implementing custom digital embedded devices. These programmable devices have the capability of being configured as many times as the user wishes in order to perform a specified application. In SRAM-based FPGAs, the configuration data is stored in a volatile memory and downloaded into the FPGA fabric to configure the embedded functional and routing resources. Reconfiguring the FPGA fabric inside the chip means that the FPGA changes its functionality on the fly to support a new application. FPGA device is typically comprised of an array of building configurable logic blocks that are interconnected to implement hardware and software designs and surrounded by I/O blocks. An FPGA logic block is typically capable of implementing a diverse set of combinational and sequential logic functions. Pipeline processors technology has been widely used in the design and implementation of computer architecture and digital embedded devices that require high levels of performance, parallelism, and flexibility. A pipeline is a set of hardware components which yields a type of instruction parallelism to the processor. In pipeline-based hardware architecture, multiple stages of processing, such as fetch, instruction decode, execute, memory access, and write back, are connected to each other to execute multiple overlapped instructions for the program written by the user. Each instruction of the program is fetched by the first stage and decoded by the second stage until the complete program is executed sequentially and perform the main task. Hardware Description Language, HDL, is a programming language used to describe the function of different applications using the concept of variables, parameters, and subroutines. The execution of the HDL code is implemented with separate hardware for each instruction in a fully parallel environment. The main objective of this paper is designing a pipeline architecture to handle 16-bit MIPS RISC-based instructions with forwarding and hazard handling. This figure shows you the block diagram for the hardware implementation of the proposed system. The design block diagram includes a diverse set of control and synchronization signals and is divided into models to decrease the development level and enhance the power efficiency of the overall design. The proposed system or the processor typically uses two types of logic elements: combinational elements and sequential elements. Combinational elements are elements that operate on data values, and their outputs depend only on the current inputs because they have no internal storage, such as the ALU unit. However, the sequential elements are elements that hold the internal state of the element, such as the instruction memory, data memory, and register file. The register transfer level of the designed processor is proposed in this figure. It is built based on the Harvard data path, which is comprised of pipeline stages: fetch, decode, execute, memory, and write back. All the hardware models of the design system are interpreted with each other by using the hardware description language in Xilinx ISE design suite. The first step of it is analyzing the data flow path inside the RISC processor, which consists of two types of elements, combinational and sequential elements. The second step is synchronizing the read and write operations with the control signal generated by the control unit. The first model of the pipeline in the data flow is the instruction fetch model. It is used to fetch instructions from the instruction memory using the current value of the program counter and increment the PC value using the adder to address the next instruction of the program. This timing diagram shows the simulation results for the behavior of this unit on the instruction presented on this table. When the program counter PC equals 1, 0, 1, 1, 0, 0 at this point, which is matching the 12th as a decimal on the table. The instruction bus update, which is shown here, we see that it is waiting until the rising clock, the rising edge of the clock occurs, which represents the multiplication operator here on the table between the register 0 and register 1. The second stage in instruction decode and read registers model. This model is used to decode the 16-bit instruction provided from the first stage, index the register file, get the corresponding data, and generate control signals for all the stages of the pipeline. This figure shows the timing diagram for the simulation results of this model and its embedded data and control signals. The register file, which is fundamental to any pipeline design. A register file is a collection of registers, typically a series of D flip-flop, each register, coupled with multiplexers and decoders that allow storing or retrieving data from the various registers. The proposed register file shown in this figure holds 8 16-bit registers and allows other components to read from any 2 registers at once using 2 read ports. We have here 2 read ports. The process of making the execution model implement different logic and arithmetic operations is realized using the ALU unit. The ALU model was designed using the concept of Boolean expressions of 6 variable Karnaugh map for the ALU of control signal and the func field signal. If the ALU output signal equals 1, 0, the operation of the ALU unit will depend on the value of the func field signal, which is part of the machine code of the instruction. For example, the ALU performs the add arithmetic operation between the 2 data rate values when the func field equal to 0, 0, 0. However, it performs AND operation when the func field signal equal to 0, 1, 0, 0. The memory access model is only accessed by 2 instructions, load and store instructions. When the load instruction is decoded, the memory read control signal is activated and the result of the ALU unit is used as address for the data memory. Consequently, the output of the memory is written into the register file. When the store instruction makes the memory write signal activated and stores the read data from the register file into the data memory. All the 3 types of instructions, which is seen here, have a 4-bit opcode, which is used to determine what type of instruction will be executed in the pipeline. Each of these instructions has a 3-bit register specification, which is used to index the register within 8 register files that I have presented. I hope that my presentation has left you with the conclusion that the design and implementation of 5 pipeline stages of a 16-bit RISC processor has simulated using Xilinx ISE design suite. The synthesis process system is realized on Xilinx device FPGA. The experimental timing results show that the hardware design of the execution unit uses 2% of Spartan FPGA chip with maximum allowable speed 56.8 megahertz. However, the hardware design of the data memory uses 8% of the Spartan chip device. The arithmetic logic unit is constructed to manage integer operations only, thus simplifying the overall design considerably. The design is synchronizing the read and write operation. If its signal is read at the same time it is written, the read value could take the old value or the new value. As a result, the edge triggering clocking methodology is used to ensure that the update process for data occurs only on clock edge to avoid any unpredictable implementation. Using the VHDL hardware description language is a flexible scheme to modify any hardware design configured on FPGA to meet future development in computer-based architectures. This work has a number of future directions in which it is heading, the most notable of which is that we need to make the RISC design more reliable and robust by embedding different fault-tolerant techniques that can detect the diverse set of faults inside the sequential logic circuits. Other future work includes evaluating the reliability and dependability level of the design system by using traditional Markov chains model. Finally, formal verification and validation methods will be used to continuously monitor, correct the operation of the safety critical hardware parts in the proposed RISC pipeline processor. Thank you for your time and attention.
Thank you very much, Mr. Karula. Dear participants, do you have any questions about this paper? I guess there are no questions. Thank you very much again for your presentation. And we will go on with the third paper with the number of 8, whose title is Packet Header Classification for Network Intrusion Detection System based on FPGA. Is Yusuf Hossein Dakhil
Yes.
here?
Yes, Victor, I'm here.
Okay, you can share your screen and start your
Okay,
presentation.
I'm gonna share my presentation with you. But just please drop this this presentation because I cannot share my presentation and our friend still share their presentation.
Okay, Mr. Karula, please could you please close your screen? Oh, thank you.
Okay.
I just stopped the sharing this.
Okay, thank you very much, and you can share now.
Yes. Now, could you see my screen?
Yes, we can see your screen,
Okay.
and you can start.
Okay. First of all, good afternoon for all the participants in this conference. My topic is talking about FPGA-based packet header classification for network intrusion detection system using SNOR tools. The outline of my presentation will be, I'm gonna give you a simple introduction about the network intrusion detection system and what's the packet classification. And after that, I'm gonna skip to the methodology. And I will show you the simulation and implementation result and conclusion and so on. So now, what is the network intrusion detection system? We can define network intrusion detection system as a security concept that will check a set of suspicious actions that can damage the availability, privacy, and resources of information. Actually, intrusion detection system classified according to their functionality into 3 essential categories. Network intrusion detection system. I'm going to focus on this field because I'm interested with it. The second one is host intrusion detection system, and the last one is distributed intrusion detection system. Also, intrusion detection system will be divided as well into 2 major approaches: anomaly-based detection and signature-based detection. So now, what's the packet classification? Packet classification is the process of classifying the packet based on the predefined rule. Predefined rule means the rule that we store it inside the RAM or ROM in FPGA memory. But classification has a major function in firewall and advanced intrusion detection system. And also the classification of package is mainly dependent on matching the header fields to an appropriate set of rules. Actually, it's a very important point. We will depend only on the header of packet. We will not use all the packet. We will ignore the payload. We will focus or concentrate on just the header. The header consists of 5 areas, which is protocol, source IP, destination IP, source port, destination port. The problem statement of this paper is to differentiate the behavior of network traffic, knowing the normal and intrusion content is very hard and consume a large time. Also, the analyst must classify all the large and wide packet to discover whose packet is valid, whose packet is damaged, in order to reflect the present network traffic. Okay, aim of this paper, design a new design algorithm which is capable of classifying incoming packets, protect the network from the intruder threats or trying, and also implement what we did to FPGA. So the methodology will consist of this word process system that can be used for packet header classification by adopting finite state machine algorithm. Show this figure shows the plot diagram of the proposed system. Proposed system consists of 4 main operations. The first one is dataset collection, from where we collected the dataset, and after that we will extract just the header from this dataset, and also we will skip to the FPGA and we will store the header in FPGA memory and compare it with the header which is coming from outside FPGA. So first of all, dataset collection is collected from different resources available at Snort website. The main component of header rules, we will focus on just the component of header rules, which is action, protocol, source IP, destination IP, and so on. And the payload rule will be ignored. So this is the example of dataset. This is the action, which means alert the user. Maybe this packet is malicious. And this is the protocol. The type of protocol is TCP. This is source IP, destination IP, and so on. So after we collected the dataset, now we want to extract just the important or just the useful data from this dataset. We would like to extract just the before using this data. It must be reshaped in an appropriate manner, where it's transformed into the data that can be processed by the developed algorithm. The payload, we will not concentrate on payload part, so it will be neglected or ignored. The header part will be represented as a predefined rule stored inside memory block within the FPGA chip, and this is this figure. This table shows the dataset that we used in our algorithm. Now this is the how could we this figure show us how can we store these dataset inside FPGA memory. We have the SIP zone. Each home will store or keep a part of the FPGA headers of the packet header. So now what's the algorithm? Packet header classification algorithm. The design procedures of the developed packet header classification algorithm were performed by using finite state machine technique. I'm going to clarify it later. And packet classification aim to find the matching between incoming packet against predefined rules, and then applying some snort action to know this packet is valid or is malicious. And the general idea of this work is to make comparison between the predefined rule and the incoming packet to classify all the ingress or incoming packet. Now this is our algorithm. we have been used the finite state machine. We have the 5 state in finite state machine. The first state is idle. That's mean the system is idle. I'm waiting to receive a bucket. Once it receive a bucket, we will go to memory fetch. This memory fetch will bring all the bucket stored inside FPGA. After that, it will go to Arching. After that, we will make a comparator. We will compare between the bucket that came from outside FPGA and the bucket stored inside FPGA. If there is any match between them, we will make an action on them. We will, for example, alert the user if the bucket is malicious. After that, update the situation and repeated this operation. By the way, this operation is done concurrently at the same time. So when the system is turned on, the finite state machine will be in the idle state, the memory fetch state, fetch all the predefined bucket as I explained. The snort operation state will be responsible for performing some if then condition. The comparator state compares the incoming bucket with the predefined rule. So this is the incoming bucket. It will be compared with the predefined rule. After that, the FPGA will be responsible about forward the bucket or ignore the bucket or align the bucket. So now I will show you just some action in this node tool. Pass, for example, this bucket is valid and pass it. Let this bucket go to its destination. And though this bucket is malicious, drop it. Alert, this is a suspicious bucket. Load, just load it. Reject this bucket and and so on. Okay, maybe it is not clear. This is a finite flow chart about my work. I will skip it. I will go to the simulation and the implementation result. Okay, the proposed bucket header classification algorithm, we implement our work by using Excellent Vivado. This is a tool for FPGA. This is it's a tool specialized to FPGA group. On the FPGA specification, well, this is the type of FPGA. Block RAM equal to, this is the specification of FPGA as well.
Mr. Hussein, your 10 minutes duration is about to over. We kindly request you to summarize your paper.
Tamam. I will show you. This is the result of my work. For example, this work is valid. It will be passed. As you know, this is a pass. This is not this invalid bucket, so it will be dropped. And this is the alert and load and etc. The throughput that we got is 174 megahertz. And these are the computing resource utilization of FPGA summary. And it's a conclusion in this cases. A new algorithm of bucket classification is presented, and that's all. Okay.
Okay. Thank you very much, Mr. Hussein. Dear participants, do you have any questions about this paper? I guess there are no questions, and we will go on with the next paper. I guess you will present the next paper again, right?
Yeah, Victor.
The paper number is 9, and the title is Survey about Green IoT Applications, Technologies, Challenges, and Future Directions.
Okay. Can you see my screen, Victor?
Yes, we can see your screen and you can start.
Okay. My second paper is talking about the survey. I did a survey about the green IoT. What is the application of IoT and technologies and challenge and the future direction? I will explain it briefly because it has many details and I have limited time, so I cannot catch up. So now the abstract, the huge evolution of technology in the area of IoT has resulted in significant change in how we work and how live. Despite the many benefits of IoT, it has to be remembered that the IoT consume energy. So we would like to have a green IoT. Although IoT consume many energy, so it pollute the environment and generate electronic waste. Both of these place a new strain on both the environment and the smart world. The demand for green IoT is ground as well, allowing us to increase the advantage of IoT while reducing its harm. The green Internet of Things is envisioned as the IoT future, which is friendly to the environment. To accomplish that, a variety of steps must be implemented to reduce carbon emissions, save resources, and encourage efficient practices for energy use. This study aims, our paper aims to provide an overview of green IoT. It also goes into how green IoT may be used. In addition, green IoT technologies are discussed. Finally, green IoT research direction and challenges are discussed. So, I'm gonna skip the introduction and the related work. We will focus on what is the, for example, application of IoT. There are many applications. For example, smart home, industrial automation, smart healthcare. IoT interfered in this field by integrating sensor and actuator within patient. Healthcare application can function better. Clinical care made, for example, monitor patient physiological status in real time by utilizing sensor to data and analyzing their bodily data and then transmitting the processes data to a processing center. For example, in smart grid, this figure shows the IoT application. For example, in a smart city, light of street, building, waste management. In smart healthcare, tracking of real-time data. In transportation, for example, also IoT based in a park, smart park. There are many technologies for doing IoT. For example, radio frequency identification. Also, a green wireless sensor network technology. This is a very good, this very important technology to make our sensor greens, which is hide from the wireless sensor network is the result of combining wireless communication and sensing. Wireless sensor network as the crucial technology that has allowed IoT to arrive. Okay. Also, cloud computing is technology of IoT. There are many technologies. I'm going to skip them. Green communication, green privacy and security. Okay. The phenomenon technological advancement of the 21st century provide numerous benefits. However, the advancement of technology necessitates a large amount of energy, which is accompanied by deliberate electronic waste and dangerous emissions. The green IoT technology was discussed in this paper. It also discussed the green IoT application. In addition, the technologies for green IoT are discussed. The green IoT and its importance in 5G communication and network are also highlighted. Finally, green IoT research direction and challenges are introduced. This paper is useful for anyone interested in learning more about studies on the topic of green IoT. The current state of green IoT and its potential future are discussed. I explained this paper briefly because it has many details and we don't have a time. Okay.
Okay, thank you very much, Mr. Hussein. Dear participants, Are there any questions related to this paper? Okay, if you don't have any questions, we will go on with the next paper
Okay.
with the number of 235. The title of the paper is Towards an Integrated Educational Games Evaluation Model, a review of study. I guess Roslina Ibrahim will present. Are you here?
Yes, yes. Yes, I am.
Okay, you can share your screen and start your presentation.
Okay, sure. You can see my screen.
It is about to come.
Is it okay?
No, we can't see now.
Yes.
There is a
Right.
black screen right now.
Okay, I will try again. Oops.
Yes, we can see your screen now.
Okay. Okay, thank you very much. Our chairperson for today. I'm Roslina Ibrahim from University of Technology Malaysia, Kuala Lumpur. We're presenting my paper, our paper actually, entitled Towards an Integrated Educational Games Evaluation Model, a Review of Study. So this presentation will be divided into 4 parts, which are introduction, literature review, analysis of factors for educational games evaluation, and conclusion and future work. For the introduction, I will introduce a little bit about what is games and what is acceptance and also what is user experience. So games are highly preferred by younger generation, as we all know, and are regarded as highly promising learning experience as well as for developing skills and competency, as done by several researchers previously. Despite many studies were done on educational games acceptance, most studies are only focusing on the issues from technology acceptance perspective, as several studies that I have listed here. So educational game acceptance among students is still low, actually, despite huge initiative and monetary fund invested by both game researchers as well as game developers, and of course the government funding and so on. Because I've been working on this field of study for about more than 5 years now. So yeah, that is basically the scenario which is happening right now. There are also hardly studies done to assess educational games acceptance from both acceptance theories and also player experience theories. So this is basically what I'm exploring for this in this study. And unfortunately, lack of good player experience can contribute to low student engagement and retention with the games, as suggested by Petri in 2016. Acceptance features consist of several components such as game usefulness, game usability, social influence, attitude, enjoyment, and so on. There are several factors. Actually, I just listed a few here. While player experience extend the assessment beyond user acceptance by integrating component of user satisfaction, aesthetic value of games, personal gratification, and so on. So this is where the idea coming from, because of from my experience from the past studies I have done in this field. I found that studies on educational game evaluation are actually separately done using different theory, whereby when the assessment was done, it is actually not completed or integrated. So that is the main problem in this study that we wanted to solve. Research on assessment of player experience is rather new in computer game application, particularly in educational computer games. complexity of educational game design feature is one of the issue also here with the design of the game itself, as compared to entertainment game, because educational games is actually combining two major components, which are the game feature itself and also the educational component itself. Yeah. So so this combination make the study highly important and beneficial to help educational game assessment. Today, educational game assessment focus only on one discipline in separate manner. For example, assessment on the usability feature, user acceptance feature, or user experience features, to name a few. Yeah, but this is among the major perspective of looking at this educational game assessment as of now. Therefore, it is important to integrate those disciplines of study and comes out with a more comprehensive assessment model. And of course, it's vital to integrate those several different body of knowledge in terms of assessing model of assessing the educational games. So in this study, some literature review has been done for the recent and most related. This paper only described the most recent and most related literature review only, because as I mentioned earlier, I've been working on this for several years. So this paper only discuss about several recent one. Yeah. So several model here which can be seen on the screen, like Lopez 2017 and also Al-Zahrani 2017. This is only a few from the perspective of acceptance theory. Yeah. So in information system, technology acceptance model is one of important theories in information system, and several theories such as by Davis 1989 and also UTAUT by Venkatesh in 2003, the most important model in the technology acceptance model, apart from some other model actually, like theory of planned behavior, theory of reason action, and social cognitive theory, and so on and so forth. And studies on acceptance factors of educational game are available mostly from the past 10 years, but highly diverse. Yeah, highly diverse due to complex nature and feature of educational game itself. And the second one is the past studies on the evaluation of player experience from the user experience perspective. Yeah, so these are among, I have listed 3 studies here in this paper, in this presentation, but several studies in my paper, which you can refer if you want to know more. But these are among the study which are highly, very closely to what I'm doing right now. The first one is a GUESS model by Fan 2016, which is, this is actually her PhD study, her PhD thesis on this matter. And she, they propose 9 components, 9 factors for the model, as we can see here. But this one is on the entertainment game that she actually used Facebook game for the evaluation and the development of this model. So my game is actually, my model will be assessing of educational game, which is, of course, some differences in terms of component must be there, because this model only access for entertainment game. But this will be a very good basis for my study because it cater for the game design feature itself. So what I'm need to do is actually to take several components from the educational perspective and to analyze to see how it should go. Yeah. And this is another 2 important study from Petri et al. 2018, whereby they look at the quality of educational game, both from player experience and also from usability features, as you can see on the left side of the screen. And my study will focus more on the blue parts of his model, of their model, on the player experience actually, yeah. And the other one on the left, on the right side is the EduGX by Vanisri et al. 2020, whereby she proposed 5 major components for evaluation of educational games, online educational game, and she named that as the EduGX model. Consists of 5 components, as can be seen here: immersion, game usability, flow, player context, and learnability, whereby each of them have several sub-components. You can refer to the paper for the detail of each of the component. Okay, this is for the analysis. Several studies from game acceptance factors here. 6.
Ms. Ibrahim, your 10-minute duration is about to finish. We kindly request you to summarize your paper.
Okay, sure. Okay, so these are the analysis for the detail. Of course, you can see in my paper, and these are the frequency of the importance of the factors for game acceptance factors. And this one is, and this is for game user experience factors, and the name of the study, and also the component on the left side. Okay, so this is a conclusion. This paper review recent model and factors for educational game evaluation from 2 perspectives, which are acceptance and user experience theory. I think I don't have to read all of this because it's actually in my paper, but that's basically what we are going to do next is to propose a more comprehensive and customizable games evaluation model, educational game evaluation model, and of course to do the exhaustive evaluation to make sure that the model will be more comprehensive and established as compared to what we have right now. Thank you very much. That's all from me.
Okay, thank you very much for your presentation. Dear participants, do you have any questions about this paper? Okay, if you don't have any questions, we will go on with the next paper. The paper number is 109. The title of the paper is Prediction of Tumor in Mammogram Images Using Data Mining Models. I guess Nur Saray will present the paper. Are you here?
Yes, I am.
Okay, you can share your screen and start your presentation.
Okay. Can you see?
Yes, we can see your screen. You can start.
Okay. The name of a project, a prediction of tumor in mammogram image using a data mining model. Breast cancer and consider one of the world's most critical health issues. Breast cancer now accounts for 23% of all cancer diagnosis and 14% of death associated with cancer. This image are their used for the detection and segmentation of breast lesion, such as masses and calcification, in order to help radiologists assess the risk of a breast cancer. Where particular shape and appearance feature is such lesion represent maker that the lesion are either malignant or benign. The next page. In this figure, progression of breast cancer at different stages. Breast cancer is thought to progress from a typical hyperplasia and detect carcinoma in situ in invasive carcinoma. The procedure for progression in of tissue section consists of the following steps. 1. Collection the tissue, removing from the body for diagnosis. Applying a fixed level to preserve the tissue. and 3, embedding the tissue in paraffin, and 4, cutting the tissue into then 3 to 5 section and mounting in its in glasses slide. And finally, iterating the tissue with multiple construction stain and to highlight different tissue section and colored feature. This is the main scope of this research work is to analyze the mammogram image to finding the tumor in the image alone. The other type of disease in the mammogram image like masses, calcification, and artifact is not included in this work. An illustration of anatomy of the breast is given in figure below. The anatomy of the breast is quite complex. Breast cancer usually starts off in the lining of the milk ducts or the lobules that supply them with milk. A breast cancer that starts off the lobules is known as lobules carcinoma, while on the develop from the duct and called duct carcinoma. Process for clustering of mammogram image. The K-means clustering algorithm and Fuzzy-C-main clustering algorithm. The K-mean is one the simple and supervised learning algorithm that solves the well-known clustering problem. The algorithm is Himmel and most used cerebral-based clustering algorithm used by main research in the current world. The Fuzzy-C-main clustering algorithm is a frequency use algorithm to examine the variance from the data and image based on the clustering ability. FCM and its different methods are utilized in the extraction of medical image. They find the disease affect region by means of segmentation the image on the basis of intensity. FCM is applied for the identification of cancer affect region in mammogram image. In this table, the description of data set. Absolutely 310 pictures are taken for examination is this exploration. These pictures are ordered as should be expect harmless and the source information in index contact 10 original picture, 106 harmless picture, and 184 picture. Original picture are the picture without growth. In the figure 1, normal picture show normal picture in which cancer is not present well. The figure 2, benign image, show benign which is abnormal and sparse cancer on the other original in. Can you hear me?
Yes, we can hear you.
Okay. K-means clustering algorithm applied to 310 image which include normal, benign, and malignant breast cancer image. Figure below shows the image with effect region for some simple image. The white color picture in this image are the cancer effect region C1, C2, represent clustering normal number. Here, C1, C2, C3, C4, and C5 stand for clustering number. the table 1 and table 2. Table 1 quality analysis of clustering algorithm. Show the result of a clustering or algorithm with the average number with color pixel. Table 2 show the result of clustering algorithm with respect to time complex. Table 2 shows 3 algorithms for the taken data set contain 300 image. From table 2, it can be inferred the MCA has less procedure time when compared with other algorithms. Conclusion: the cancer effect region when identified in the 5th clustering in K-means and FCM algorithm. However, in MCA, it was identified in the 4th clustering itself. When comparing all the 3 algorithms, MCA provides better result than the other 2 algorithms. Finding tumor effect area by MCA algorithm is better than the other algorithm. Thank you. Any question?
Okay, thank you very much for your presentation. Dear participants, do you have any questions about this paper? Okay, I
Can
guess.
I ask a question?
Yes, sure, please.
Miss Noor, where did you get the data for this study? Yeah? No, can you hear me? Are you using real data or I can't hear?
Miss Noor, can you hear us? I guess connection lost.
Yeah, that's okay. That's okay.
Okay, then we will go on with the next paper. If she comes back, we can ask her again your question. The next paper number is 224. The title of the paper is A Quick Performance Assessment for Artificial Electric Field Algorithm. I guess Mr. Adegboye will present the paper.
Yes, sir. Good afternoon, sir.
Okay, if you are ready, you can start your presentation.
All right, sir. Can you see my screen?
No, we can't see your screen. Yes, now we can see your screen and you can start.
Okay, all right. So my name is Adegboye Atayami from European University of Lefke. My research is in the area of meteoristic search algorithms, and this work was written by myself and Associate Professor Dr. Ezgi Denise Uka. The topic of the work is a quick performance assessment of artificial electric field algorithm. In the abstract, just a quick summary of what was done. We used several meteoristic algorithms in this literature to solve complex problems from different fields. And in this work, we compared artificial electric field algorithm with several other state-of-the-art meteoristic algorithm for like particle swamp optimization, ant colony, and harmony search. And in this work, we compared them on two qualities. One is the ability to converge at the global optimum value, and also to their resilience in keeping track of the global optimum value in the case of a dynamic environment where the global optimum value keeps shifting based on the frequency. And to accomplish this task, we use two benchmark functions, the static and the dynamic type of benchmark function. A little information about artificial electric field algorithm. It is inspired by Coulomb's law of electrostatic force. We state that the electrostatic force between two particles is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. And the velocity of this charge at any point is equal to the sum of the previous velocity fraction and velocity variation. The variation of this velocity or acceleration of some charge is proportional to the force acting on the charge and is divided by the particle's mass. And for each potential candidate solution to a given problem, in our case, a benchmark function, AFA has a set of charged particles. Each charged particle contributes to the deciding efficiency of the candidate solution. So each candidate solution in AFA is viewed as a charged particle. And AFA employs the use of the electrostatic force of attraction, whereby each charge attract one another, and it results in global migration towards the particles with the higher charge in the electrostatic field. And the location of the charged particles and the fitness function that defines their charge and unit mass contribute to a candidate solution. This flow chart illustrates the steps of artificial electric field algorithm, or what you can call AFA. Firstly, we randomly initialize the position of these particles in the electrostatic field, and then we compute their fitness values. The fitness value is as a result of the benchmark function being used, and we calculate the best particle, and depending on what type of problem you're solving, either a maximization or a minimization problem, the best particle in the case of a minimization problem will be the particle with the least fitness function, and the worst particle will be the particle with the highest fitness value. And we also calculate the acceleration, and again, we calculate also the force. And next is we use the information to update the velocity and the position of the particle. And if the stop criteria is fulfilled, in our case, of AFA, we use numbers of iteration. So if we get to the maximum number of iteration, we would return the best particle. If not, then we'll go back to step 2 and continue iteratively until we get to the last or the maximum iteration value. In the experiment, we made use of two types of benchmark function, the static benchmark function and also the dynamic benchmark function. And for the static benchmark function, we use a more complex kind of problem that is called the multimodal static benchmark function. It has several global optimum value, which tends to try the capacity of the algorithm to explore or to exploit the search space to look for the best amidst all the global optimum value. And again, we use the dynamic benchmark function, popularly called the moving peak benchmark function, which periodically, the landscape change periodically, which affect the height, the width, and the position of the peaks in the search space. And concerning the result of the static benchmark function comparing with ant colony optimization, harmony search, and particle swarm optimization, AFA got the best value in terms of standard deviation, which gives a reflection of how consistent AFA is able to get to the global optimum value. And to obtain this result, we had 40 independent runs to obtain the result you see right in front of you. And AFA is also able to get the best average value. And also overall, AFA is able to produce the best result. And also for the dynamic function, we also add 40 runs, which illustrate the offline error and the standard deviation. And again, AFA is able to achieve the best result for the offline error and the standard deviation. So concerning the result for the static benchmark function, which tries to test the balance of exploration and exploitation. Exploration in the sense that the AFA can move around the search space effectively to find regions of where there is the global optimum value, and exploitation in the terms of when it gets to a region where there is a global optimum value, AFA is able to explore that particular region and obtain the best global optimum value. So for the static benchmark function, it shows the stability in the structure of AFA to both explore and exploit regions of global optimum value. And for the dynamic function, if I've been able to obtain a good standard deviation value in terms of offline error, it illustrates the robustness of AFA in the sense that for the dynamic benchmark functions, the landscape of the function change periodically depending on the set frequency, and which means the global optimum value is always moving depending on frequency. The landscape keep changing. So it shows how versatile and how robust AFA is and able to track down the global optimum value in spite of the condition of the function evolving over time. And in terms of conclusion, the result denote that for both of the function, AFA performs better than the other selected algorithm in comparison. This indicates that the properties of AFA, such as robustness, exploration, exploitation, are well structured for solving optimization problems. Therefore, it can be concluded that AFA can be preferred as a qualified algorithm for solving complex problems. Thank you for your rapt attention.
Thank you very much for your presentation. Dear participants, are there any questions related to this paper? Okay, if you don't have any questions, thank you again. We will go on with the next paper. Our next paper number is 55, but I guess the authors are not here. And our first paper was, the number of the first paper was 31, and I guess the authors are not here. Am I right? And we have one more paper from the previous session, 7.4. The name of paper, the title of the paper is "The Role of Machine Learning in the Healthcare Sector: A Roadmap to the Potential Prospects." Edmira Ixafera will present. If you are ready, you can start. We can't hear you.
Hello everyone.
Yes, we can hear you now. You can start.
Okay, I'm Edmira Ixafera, a lecturer at Alexander Masiu University of Durrës, Albania, and the other author is Floria Ismaili, and our article talks about the role of machine learning in the healthcare sector, a roadmap to the potential prospects. The content of this study is as follows: abstract, introduction, background, research methodology and questions, results and analysis, conclusions and references. The purpose of this study is to investigate the potential prospects using current literature in the domain of machine learning to assist healthcare practitioners in utilizing machine learning models. This article reviews published papers providing code and targeting the research in machine learning from both perspectives, computer science and biomedical information science. We have reviewed 70 studies, discovered that reducing the amount of time the use of those automated machine learning systems can assist in matching or improving human expertise, in particular machine learning scenarios at small and medium data sets. Can I start?
Yes, you can go.
Okay. Even though there is a significant work done in the domain of machine learning for healthcare, further work is required for the extensive adoption of machine learning in healthcare department. Due to vast gathering of healthcare data via electronic clinical records or digital health devices, machine learning is a crucial approach that has proved the potential to convert those massive health data sets into useful information in various applications. Also, the patient safety, quality of treatment, as well as the reduction of healthcare costs may be improved by using machine learning models. Machine learning has already been effectively employed in a variety of medical applications, including classifying clinical objects at a higher risk of being moved to the intensive care unit, or uncovering primary signs of lung cancer, identifying fake and offensive claims for health insurance, and diagnosing respiratory disorders using X-ray technology. Anyway, developing and deploying machine learning solution is still challenging because data and human knowledge are often unavailable. Researchers don't have the expertise to employ machine learning predictive models to large data sets, and the lack of collaboration between researchers and data scientists. This slide presents the components of machine learning timeline, starting with pre-processing, feature engineering, model training model, hyperparameter optimization, and model validation, validating machine learning models using different evaluation metrics. This review will discuss how machine learning is particularly beneficial in the healthcare area, and we will discuss automated feature engineering, hyperparameter optimization, and pipeline optimizers. Background, despite the rising body of the research in the subject of machine learning, little effort has been done to apply these approaches to the field of healthcare due to high quality and representative data sets and the lack of faith in the automated machine learning application. However, several minor applications of automated machine learning in the healthcare sector have been developed, like ML-BCD and PredictML, that assist in automating machine learning for large healthcare data. Autoprognosis is another application that has been developed to automate the configuration of a machine learning pipeline optimized for clinical predictions. The autoprognosis approach improves the accuracy of the risk prediction regarding cardiovascular diseases. The developers of this application conducted empirical studies demonstrating that their automated approach beats standard clinical applications, TPOT, AutoSclern, AutoWeka, and in area under the curve settings for prognostic modeling. Here are the criteria we have used to select the papers, and below are the proposed research questions. There are 3 research questions, and the 70 selected papers are reviewed based on them. First research questions talk about which automated feature engineering techniques can be employed in the domain of e-health machine learning. The second question is which hyperparameter optimization strategies can be employed in the domain of e-health machine learning. The last is which pipeline optimization strategies can be employed in the domain of e-health machine learning. Here is the analysis for research question 1, automated feature engineering. Effective AFE entails the development of features that give meaningful intuitions into the data and account for the learning algorithms limits. AFE frameworks have been developed to create an innovative set of features that increase the quality of succeeding machine learning tools. Platforms like Campbell-3 and grant challenges in biomedical image analysis 4. Okay, here we have analyzed several AFE strategies like expand reduce technique. This technique was a pioneer for constructing data science machine. Also, the advantage of this technique is that only one modeling phase is required on fitting feature selection. And disadvantage is that doesn't consider function compositions and suffers from execution bottleneck during the AFE stage. Some applications that are have been developed following this technique are ExploreKit, one-button machine, auto-learn, and feature tools. Genetic programming technique, this was a system like an artificial chromosome, utilizing a tree-based algorithm that can be used for both features building and selecting features. This strategy yielded good outcomes in specific studies and is faster than the expanded reduce. And the GP feature construction is developed following these techniques. Meta-learning technique following this was created. Learning feature engineering approach works by inferring the true effectiveness of a particular transformation, e.g. arithmetic or aggregated operators and numerical features based on prior experience with feature engineering. Hierarchical greedy search technique is applied to create Cognito, which investigates alternative feature building options while gradually increasing the model's accuracy using a greedy search technique. Reinforcement learning, RFLE approach, in which a reinforcement learning agent is used to explore a transformation graph. And here is given in the form of a table what we explained in the previous slide. There are strategies and are presented application following those strategies. Here is the analysis for research question 2, hyperparameter optimization. Optimizing hyperparameters is sometimes seen as an art, demanding professional expertise and approximation, and occasionally a brute force search. Machine learning researchers have suggested numerous alternative ways for automatically selecting hyperparameters to make machine learning more approachable to non-technical individuals. And here are presented some techniques for optimizing hyperparameters. Greedy search, it is a brute force technique that takes a limited number of values from the users from all hyperparameters and calculates the Cartesian product of the values. Random search is a straightforward alternative to grid search, which randomly selects hyperparameter values from a user-defined collection of hyperparameter configuration until the budget is depleted. Optimization from samples, redirected searching procedures that repeatedly produce new configuration settings depending on the execution of proceedings configuration values. And in this regard, particle swarm optimization and evaluationary strategies are two notable examples of those approaches, and both are motivated by biological tendencies. Bayesian optimization has appeared as the cutting-edge optimization methodology for automated machine learning applications. Bayesian optimization is an iterative and probabilistic technique composed of two fundamental mechanisms and a causation function and a surrogate model. Numerous open source Bayesian optimization implementation are available, including HyperRAS, HyperOpt, Spearmint version of Google Visor, SMAC, and Talos. Two authors, Lang and Liu, in their study present a Bayesian optimization implementation that uses progressive sampling to develop a platform that enables medical researchers to execute machine learning independently. So the BOHB method combines Bayesian optimization concepts with hyperband, that is search approach that leverages consecutive halving to create a more resilient and efficient hyperparameter optimizer that scales. Anyway, we have suggested or citated some other articles to go deeper into our review.
Miss Ixapera, your 10 minutes duration is over. We request you to summarize your paper.
Yes. For a machine learning application to be independently usable by a non-expert, it is necessary to develop automated machine learning approach. This section discusses those applications, referring to as the pipeline optimizers strategy like AutoWeka, AutoSclearn, TPOT, TubeBug, MLPlan, etc. In this table are summarized the applications and activities performed by each of them. At the end conclusions, this study examined different approaches to automated machine learning, including hyperparameter optimization, automated feature engineering, and pipeline optimization strategies. The reviewed AFE techniques include expand, reduce, meta-learning, genetic programming, etc. Different HOS strategies comprise of greedy search, which is considered the easiest approach, random search, optimization from samples, Bayesian optimization. POS strategies embodied AutoSclearn, AutoWeka, TPOT, etc. And this study finds certain flaws in existing auto machine learning techniques, particularly their inability to deal with the volume of diversity of data seen in biomedical settings. And of course, also this is very useful for researchers in the healthcare field who want to use data science approach. They can use this survey as a starting point. Thank you for your attention.
Thank you very much for your presentation. Dear participants, do you have any questions about this paper? As I can see, there are no questions. We have two more unpresented papers. Their paper numbers are 31 and 55. Are the authors of this paper here?
Yes, I'm here for 31.
You are here for 31?
Yeah.
The title of the paper is Energy Efficiency Performance for Next Generation Wireless Communications.
Yeah.
Okay, you can start now. You have 10 minutes to present your paper.
Okay. Give me a minute.
Okay, we can see your screen and you can start.
Okay. So my topic is talk about the energy efficiency performance for the next generation for wireless network, wireless communication network. Actually, we talk about the 5th generation of the mobile wireless network. We consider and we take the matter of energy efficiency as objective for this study. So here in the introduction, we talk about the communications that being between the mobile station and the antennas that used in the base station. So we have here the multiple input, multiple out antennas have each base station have at least 10 and more than antennas used to transfer the data from the base station to the user, and reverse from like as uplink and downlink. So the growth demand of wireless communication and its application lead to, because agreed to effort should into researcher consider to meet the future requirement of wireless network. And it's expected the for traffic will reach a multiple hundred than this nowadays, and we need to increase the capacity of the network with high and efficiency energy and high bandwidth and high throughput. So this is the most important thing that we need to talk about. Also, the configuration lead to high energy efficiency for large number of base station and user density. Here the increase of network capacity has limitation for requirement system energy efficient, which can be called trade-off between energy efficiency and spectral efficiency, because we have at least one, from 3 multiple of 3 or 4 multiple 4 antenna in each base station, and reach to 100 antenna. We know for 5G wireless communication, the antenna was a small antenna because the high frequency from millimeter wave. So the frequency started from 28 gigahertz until 300 gigahertz. So this high frequency make us, we need a small antenna called small cell. Another thing, they talk here about the challenges. And before the challenges, we need to talk about the aim or the goal of this article or this paper. So the aim of this paper or article to make a full overview or practical simulation uses small cells as massive MIMO, multiple input, multiple output antenna deployment in network for 5G network as simulation. And we talk about the effect of changing user density and base station density and the effect on the energy efficiency for this scenario. So the challenging here is the current network phase work to maximize the capacity by improving the transmit power regardless the huge growth of number of connected devices. So here we using more and more energy to increase the communication capacity, would result in unacceptable operation cost. So now we here at, as we see, we can summarize the limitation or a problem statement is to maximize the capacity by improving the transmitted power regardless the huge number of user or connected devices, because it will be mobile phone, laptop, tablet, or even cars, or when we talk to vehicle or vehicle to infrastructure, they need high transmitted data to connect between others. So here we use the methodology. Actually, we used for dense station or deployment small cell. We used position point process called HPPP. It's like a methodology that we used with 2 different scenarios. The first scenario is when they manage the network as a star topology, and another work we deployment the antenna as mesh topology. The difference between us, the mesh topology, we have just one center base station can transmit the data, and star topology, each one has on space station. We of course we will prefer the mesh topology, because if one of the base stations or turned down, it will another still working and use the transmitting and receiving the data. Then we will get the result. So here our simulation result, we depends on three things: the number of small cells, which means the number of antennas that we deployment in network area, and the energy efficiency that we use about megabit per joule, and how that goes from them. So the simulation result obtained from the simulation of applying random deployment of small cells antenna. So this figure, or the figure one here, you will see the energy efficiency with verifying of the number of small cells to determine the goal here, to determine the effect of changing of number of small cells regarding to, especially for energy efficiency. So this work comparison between using two main configuration for 5G for energy efficiency valuing, and for the first configuration he will see the small cells configuration of radius verified from 5 millimeter to 50 meter, so 15 to 50 meters simulated, and we used from 20 to 100 cells as my small cells antenna. And the difference of for the signal noise ratio consists of from 137 are considered, which are the corresponding target of the target of SNR. So here the SNR, it will be reached until 6 megabits per joule, and when the small cells have until 20, the signal to noise ratio number one that we called one has a blue color will reach till 5 or less, or 5.5. So we'll see the decreased, we have decreased in the signal to noise ratio in this method. Until we here talk before completed, here we talk about the parameter that we used for the previous and the coming result. So the area of simulation is 3 kilometers and transmitted with 0.05 watt, path loss 3.4, and also the bandwidth of the channel is 100 kilohertz, and the signal to noise ratio, as we saw in the previous graph, it's 1, 3, and 7. Number of antenna 10 to 91. So here also we see when we increased the small cells and the related with energy efficiency. So when increased the small cells.
Sorry, your 10 minutes duration is over. Could you please summarize your paper?
Yeah, this is on the last thing. So this is the simulation result for the end one, is the effect of hardware improvement. So talk between the hardware improvement and energy efficiency, and we'll get the signal to noise ratio is higher than the other. It was like 12 energy efficiency megabit per second until joule. So here we have the conclusion. The conclusion talk about increasing both coverage area and capacity for wireless network, and the goal of this project of this paper to make full overview of practical simulation, use of a small cells deployment and 5G regarding for charging density between base station and the energy efficiency. And the studies has proved the small cell to affect for energy efficiency as much as we use multiple massive onboard, massive output. And that's it. And thank you for all. That's all.
Okay, thank you very much for your presentation. Dear participants, are there any questions about this paper? Okay, I guess there are no questions. And we have one more paper. The paper number is 55. Is the author of this paper here? I guess the authors of this paper, paper 55, are not here. And dear participants, we would like to thank you for attending the Congress. We hope to meet you in next conferences. I'm going to end this session now. Thank you.